In order to solve a system of equations by graphing, you will need to find the point of intersection, where the two lines cross. Recall that in order to graph a line, you must have two things, the slope and y-intercept. If your equation is already in slope-intercept form, then you can start right away with the graphing. Start with your y-intercept first, graph that on your y-axis, and then use your slope to find other points on the line. We have two lines here, y equals negative 3x plus 4 and y equals 3x minus 2. I'm going to graph them each individually and then find out where the point of intersection is. Starting with our green equation, y equals negative 3x plus 4, the slope of this line is negative 3, which I can rewrite as negative 3 over 1. That makes it easier for us to write the direction in which the points will travel. So negative 3 over 1 is going to be down 3 points, right 1 point. Your y-intercept, or your b value, is 4. That is your starting point. So when I graph this line, I'm going to go up to 4 on the y-axis, because that's my b value, my y-intercept. Then I'm going to go down 3, right 1, until I hit the edge of the graph to find every other point on this line. So down 3, right 1. Down 3, right 1. Down 3, right 1. And that's when I hit the edge of the graph. Draw your line. The more points that you have, the more accurate it's going to be. The second line, the blue line, your m, your slope, is 3, or 3 over 1. And that corresponds to movement of up 3 and right 1. Your b value is negative 2. So you're going to start this line at your y-intercept of negative 2, right here. And then you're going to move up 3, right 1 to find other points. As you notice, you move up 3 and then right 1, you end up plotting a point that's already been plotted. That is the point of intersection. Keep that point in mind. Complete the rest of the line to make sure it's neat with a graph. To go the opposite way, you're going to go down 3, left 1, and draw your line. The point of intersection is right here, and that point is 1, 1. So your solution to this system is x equals 1, y equals 1, which is the point 1, 1. Now, if you're unsure on whether or not you got this correct, you can check your answer by plugging the solution back into each equation. So with the first equation, I can write 1 for y equals negative 3 times 1 for x plus 4. Negative 3 times 1 is negative 3. Bring down plus 4. Negative 3 plus 4 is 1. 1 equals 1, that checks out to be equal. Test the second equation. Plug in 1 for y. 1 equals 3 times 1 for x minus 2. 3 times 1 is 3. 3 minus 2 is 1. So that checks out. So if you've plugged the point back into both equations and you get it to be a true statement, then that means that is your point of intersection. If you check your answer and you get the two sides that aren't equal, that means you have graphed the two equations incorrectly. In our second example, we have two equations that are not in slope-intercept form. In order to graph these equations, we are going to change each equation into slope-intercept form. In order to do that, we need to solve each equation for y. Starting with this blue equation, we're going to subtract x from both sides. And you get negative y equals negative x plus 3. We're going to put our x term first, because in slope-intercept form, the mx term comes first. So it makes it a little bit easier to see where the slope's at. Your next step is to divide everything by negative 1. And you'll get y equals 1x minus 3. So that means the slope is 1, or 1 over 1. which corresponds to a movement of up 1, right 1. Our b value is -3, so that's our starting point. So our y-intercept is -3, we're going to start there, plot a point, and we're going to move up 1, right 1 until we hit the edge of the graph. So keep moving up 1, then right 1. And if you want to fill in to the left, you're going to do the opposite direction of up 1, right 1, so down 1, left 1. So that's your blue line. The next equation, 7x minus y equals -3, is also not in slope-intercept form. So we're going to subtract 7x from both sides. Get -y equals -7x minus 3. Then we're going to divide both sides by -1. Y is going to be equal to 7x plus 3. Your slope here is 7, or 7 over 1. Your b value is 3. For 7 over 1, you're going to move up 7, right 3, or right 1. And you're going to start your line at +3. So up here on your y-axis, your y-intercept is 3. Start there. And you're going to go up 7, right 1. But you'll notice that you can't move without going off the graph. So you need to do the opposite of up 7, right 1, which is down 7, left 1. So count down 7, left 1. And you notice that you've already made that point for the blue line. So that is your point of intersection. We can only graph 2 points on this line due to the steep slope, but we have enough points to find out where our point of intersection is. And that point of intersection is -1, -4. Again, if you're unsure of your answer, check them, plug it back in. You can plug it into the solved slope-intercept form equation, or you can plug it back into the original, doesn't matter. I'm going to plug it back into the original. So for the blue one, it's going to be -1 minus -4 equals 3. -1 minus a -4, that's going to be -1 plus 4, which is 3, equals 3. That checks out to be okay. The second equation, I'm going to plug into the original. So 7 times -1 minus -4 equals -3. 7 times -1 is -7. Minus -4 is +4. -7 plus 4 is 3. So that checks out as well. So this is the solution to our system.